Did you know that an odd times an odd is an even? Math HL.
Hey, Ropke here. We're on 2e, even and odd functions. I'll just say right now, this particular section, I don't think you're really able to appreciate how valuable it is just yet. Most of the example problems that I'm going to show you are either really easy or just really algebraically dense and challenging and not the sort of thing that's going to show up in this course at all. Um, the idea of even and odd functions are definitely helpful within certain contexts. And when we see those contexts, I will let you know. Um, but for right now, it's at least an easy enough thing to kind of talk about. So here's the algebraic definitions. An even function, f of negative x is equal to f of x for all x in the domain. So some of my favorite examples of an even function, cosine, cosine curve, if you know your trig. Really any type of simple even polynomial, so y equals x squared or x to the fourth or x to the sixth, as long as they're that parent function, then it's going to be even as well. So graphically, we're looking for something that's symmetrical over the y-axis, whereas with odd functions, we're looking for something that's going to have rotational symmetry around the origin. So like a sine curve is going to be odd, so is the tangent curve. And again, any odd parent function, so the line y equals x, the cubic y equals x cubed, x to the fifth, and so on. Those are all going to be odd functions. Let's put it to use now with some easier ones. Here's a random function, f of x is odd, so we know that as a point of fact. It's an assumption we're starting from. All right, so let's put it into action here with some easier ones. Here, we know ahead of time that f of x is some odd function. So f of negative x is equal to negative f of x. We're just asked to simplify this fraction. So f of negative c is equal to negative f of c. So this is minus 3 f of c minus 5 f of c divided by negative 4 f of c, just using the rule for what an odd function is. And then clearly I can simplify this. It's going to be negative 8 f of c divided by negative 4 f of c, and it's just 2 f of c. Simple. Here's another easy one. So we're told that this is an even function this time, and we just want to figure out what a is. So again, I'm just going to ask myself, well, what is f of negative x? That's going to be negative 2x plus 3 times negative x plus a. But that has to be equal to f of x. So that's equal to 2x plus 3 times x times a. Well, all right, let's multiply some things together and see what we get. On the left, we're going to have 2x squared minus 2ax minus 3x plus 3a, and that needs to be equal to, on the right, 2x squared plus 2ax plus 3x plus 3a. And some things are going to cancel. Goodbye, 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 goodbye. Um, combining like terms, moving everything to the same side, we're going to get 0 is equal to 4a plus 6. I'm going to factor out the x from both of those terms. Since a is a constant value, um, now from here, I mean, I could figure out, okay, well, maybe, maybe x is equal to 0. Of course, if x is equal to 0, then negative x is still that same point, so that's not really telling me anything interesting about the function. That's just looking at one value. Um, but the other option is that 4a plus 6 is equal to 0, which would mean that a would be equal to negative 3 over 2. And if you put a in as negative 3 over 2, you get a function here which is even. And now things are going to get needlessly complicated. I'm not going to do all of these, but we have a quadratic function, ax squared plus bx plus c. And we're being told in advance that it is an even function. I mentioned before with my favorite examples, I said, you know, like here, these ones I drew, they were the parent function or the mother function for each of these. So just the simplest type. And this parabola, I was imagining just x squared. So a is 1, b is 0, and c is 0. This problem is telling me that if that parabola is even, the b value has to be 0. Let's see why that is. So again, we're checking f of negative x to f of x. This is f of x. This is f of negative x. When I square negative x, I still just have ax squared, but now it's going to be minus b of x plus c. We can see from this that things are going to cancel, and I'm going to have bx is equal to negative bx, or 2bx is 0. That's only going to be true all the time if b is equal to 0. Now you can do the same process for a cubic function. Now here we're not being told the answer in advance, but we're going to need to figure out what might a, b, and c have to be, and d. And you could try it again for a quartic. It's going to be the same ideas, but I just don't really want to. I didn't find those problems to be very interesting. All right, what was I talking about in this video's intro? I said that an odd times an odd is an even, and that is true if I'm talking about functions rather than numbers. So we need to clarify in this course whether we're talking about functions, numbers, are they real numbers or are they complex numbers? Later on, we might be making statements about vectors that are not true for numbers, but don't worry about that until next year. They're important nouns here that we should be using. So it is true that the product of two odd numbers is another odd number. However, the product of two odd functions is an even function. Let's see why that might be. We'll just do letter C. The other two are done similarly. If I have two odd functions, so I'm going to call them f and g, they're both odd. So I just want to give this product a name, okay? I'm going to say that f of x times g of x is something called h of x, okay? Now I know that f of x and g of x are both odd, so that means that f of negative x times g of negative x, which happens to be equal to h of negative x, by definition, this should be equal to, well, f of negative x is equal to negative f of x. G of negative x is equal to negative g of x. And then this negative times this negative, that will make a positive because those are negative 1 times the functions. Those are numbers. So that gives me f of x times g of x. And this must all be equal to h of negative x. So wait a second. H of negative x is equal to this function, but h of negative x is also equal to this function. Notice here that I have an even function rule happening because I have the same thing occurring when I have positive x and negative x. The product of two odd functions is an even function. And finally, we'll close this out. We're assume that f is an even function and g is odd. What's the composite going to be? Could be neither. Most functions are going to be neither, I suppose. Well, let's approach this the same way. So f is even, and I like just writing out the rule for every function that I'm working with so that I can use it appropriately. So f is an even function, and g is an odd function. And I want to know f of g. So the question is, what happens when I put in instead of f of g of x, what happens when I put in f of g of negative x? If this ends up being f of g of x, then I know that I was dealing with an even composite. If it ends up being negative f of g of x, then I'll know it was odd. And if it's something else entirely, I don't know, we'll see what that might look like. Maybe. Then it'll be neither. So, what happens? Well, working from the inside out, we know that g of negative x is equal to negative g of x. So this is now f of negative g of x. But I also know what happens when I take f of negative whatever its input is. Since f is an even function, that's just going to equal f of g of x. And there I have my answer. This ended up being an even function. The composite in this case of an even and an odd in this order is an even function. But again, what if I'd done this in the opposite order? What if I had done g of f of negative x? Well, g of f of negative x is going to be equal to g of, well, this is actually kind of boring, isn't it? It's just going to be g of f of x. So I kind of have my answer right there. It ends up being even actually in either order that I do the composition, which kind of neat, perhaps unexpected as well. Anyway, that's all for even and odd for now. Again, this will be something that will be much more interesting, I think, later on in the course.